Hello. So, the remaining part of yesterday's lecture, we will talk about a very famous scientist that is Amedeo Avogadro. Back then, there was like no very a lot of classification between the physics, chemistry, and mathematicians. So they kind of worked in most of these fields, and like the physicians were also good mathematicians, and the mathematicians were also good chemists. So they were like working in in multiple fields of science. So he was also a very good scientist. So he was Avogadro was born in 1776 in Italy. He was son of a lawyer and senator. Um, his family was very famous, like they were very renowned lawyers, and he was expected to have a career in politics. So following the legacy of his family, he earned a doctorate in law and worked as a lawyer for 3 years. After that, he was inspired by the work of some mathematician, so he started studying math and physics with a private tutor. um, the, the interest got like, oh, he was much interested in these fields of sciences. So he decided to make a career in natural science rather than following the legacy of his family to enter the field of law. So he became a professor at the College of Vercelli. So Avogadro was like, he was inspired by the work of Alessandro Volta, and Volta was the inventor of the modern day battery. So, and the he worked with his brother on some physics problems, and this work with his brother earned him a nomination to the Royal Academy of Science of Turin. And this was like the turning point for his career. This gave him the recognition as a serious scientist. Before that, he was still considered to be like a person who had just changed his field, not an expert. But after that, he got famous and he got recognized as a scientist. He discovered the SI based units to measure the amount of particles in a substance. In our chemistry lectures, we discussed about the mole, and we talked about the number of particles, like the atoms and molecules are so small that there are millions and millions of atoms in a very very small substance that even we cannot see with our naked eyes. So his discovery was initially that how much amount of atoms and elements would be present in any like in any specific quantity. For example, if you are taking um, 10 grams of sodium chloride, so how many atoms of sodium chloride would be present in in that in that much amount? So this was his major discovery. This is known as Avogadro number, and that is 6.022 into 10 exponent 23. This is a very huge number, like some trillions of trillions of trillions of trillions time. So this much amount of atoms are present in 1 mole, and 1 mole of anything, like 1 mole of sodium chloride, would be equal to the atomic masses of sodium and chloride, that is 35 and 23. So if we add 35 with 23, we get 58, I think. So in 58 grams of sodium chloride, this much atoms or molecules of sodium chloride would be present. So this is calculated because the amount of grams per mole or grams per this much atoms is equal to the atomic mass of an element that we are discussing. That one mole of any substance, like one mole of any molecule or atom, would would contain this much atoms. So by this we can even assume the size of an atom. The size of an atom is very small, because this is a huge number, and these numbers are present in just like few grams of an element. So he figured this out trying to explain observations made by Joseph Gay-Lussac that combining equal volumes of gas under some circumstances didn't lead to any measurable increase of total gas volume. He explained that a chemical reaction formed a new gas with the same amount of particles. So initially, uh, some observations were made by the scientist named Joseph Gay-Lussac, and they were not sure about the results they were getting after some chemical reactions between gases. So he explained that the chemical reaction, uh, it actually formed a new gas with the same amount of particles. This hypothesis was not accepted until 4 years after Avogadro's death, when a colleague again presented Avogadro's work to the science community, showing that it helped to explain and solve some of the outstanding problems at the time. So initially, his work was not accepted. It was rejected that like this is some serious chemical problem, and just imagine what would be the scope like 250 years ago. So he tried to explain his theory, but that was rejected by the science community. But after his death, it was again presented with some with presentation from like his colleague, and eventually not just accepted it, it helped them to solve some of the outstanding problems at that time. So Avogadro's discovery of the mole led to better estimates of the relative weights of a variety of elements. The mole connects the world. We cannot see to a world we can measure. So the mole is the unit in which we measure the amount of quantities. So the mole could be used to determine atomic mass as well as molar mass, and the of link the amount of particles to the mass of substance. So this is what we have been doing, we have been talking about, and this is like the major finding we or the major achievement that we have done through Avogadro's number is to find the number of atoms in a specific amount of gas, or number of atoms in a specific amount of substance. So if we are given with um, any any mass quantity of any element or compound, like for example iron sulfate, magnesium, copper, so we can find the amount, number of atoms, number of molecules in that given substance or given quantity. So Avogadro's studies gave a better distinction between molecules and atoms. So he revealed that John Dalton had confused the concepts of atoms and molecules. So it not just like he presented with the new quantity that is known as mole, but also it gave a better distinction between molecules and atoms. So initially he also like disapproved the theory presented by John Dalton, and he thought he confused the concepts of atoms and molecules. So let me share another slide. So the mole is the molecular weight of substance in grams, and this much atoms of hydrogen would be equal to 1 mole of hydrogen, or you can say this much moles of uh, aluminium atoms would be equal to 1 mole of aluminium. final slide. Okay. Avogadro publications and awards. So it, Avogadro wrote his note regarding in which he declared a hypothesis which is now known as Avogadro's law. The hypothesis he shared about the quantity of atoms in one mole is known as Avogadro's law. So, and he also wrote another note about gases in 1814. So Avogadro was the first chair of mathematical physics at Turing University in 1820. Although, uh, like he had a doctorate in law, but just imagine how was his struggle and how much passionate he was about science. Okay, so this number 6.6 into 10 raising by 23 is considered to be Avogadro's number. He carefully thought that particles are composed of molecules and that molecules could be composed of simpler units such as atoms. So the number of molecules in one mole was called Avogadro number. So this number has been experimentally determined also. So the Avogadro's law stated equal volumes of gases at the same temperature and pressure contain the same number of molecules, regardless of their chemical nature and physical properties. So he helped fix the confusion between the atoms and molecules. He stated that gases are composed of molecules and molecules are composed of atoms. It was proven that Avogadro's law determined not only molecular masses but atomic masses as well. So, Amedeo Avogadro is hailed as the founder of the atomic molecular theory. So, this was an introduction to Amedeo Avogadro because we studied about Avogadro's number. So, thought that we should have an introduction with the scientist also. So that's it for today.